This is the first assignment for the third quiz in the second try of Algebra 2. And this is going to be pretty much a review session for solving right triangles. So there are four main things you need to know when attempting to solve for a right triangle. And they are two things: when you know two sides, you're going to use the Pythagorean theorem or right triangle trig, but Pythagorean theorem is generally the better approach. If you know two angles, you're going to use triangle angle sum. Three angles add to 180 degrees. If you only know one side, you're going to use trig, a trig setup to solve for one of the sides, and then perhaps a trig setup to solve for the remaining side, or the Pythagorean theorem, and then trig setup to solve for an angle when you only know the right angle. So it's based on whether you know two sides or two angles, which is generally not the case. You generally know one side or one angle. The other thing that can happen is that you might just be writing a trig ratio in a right triangle. And so you see this abbreviation here for the first three trig ratios. So katoa, that stands for the sine equals the opposite side divided by the hypotenuse. Let me zoom in here. The cosine equals the adjacent side divided by the hypotenuse, so on and so forth. Tangent is opposite over adjacent. So those first letters in everything there makes the abbreviation. So we'll try to highlight that first letter of each there. Also, there are the reciprocal ratios, which we don't use in solving a right triangle, but they can be stated. Okay, so be aware of those, that you might be asked to do those. So I'm going to do a few of the problems on this first assignment. It is a lengthy assignment just because you need a lot of practice on this. And my advice is, as always, do enough of these so that you are sure that you know what's going on. So cosine of angle R. So what I would do is I would take each angle and do all the ratios. So with respect to angle R, this is adjacent, this is hypotenuse, this is opposite. And so that's every time how you begin the trig process. So the cosine is simply the adjacent side divided by the hypotenuse. But I would recommend to put the labels on there so that you can see it. But I would answer all the sine, cosine, and tangent of angle R first, and then set it up for angle S, which all that changes is the adjacent and the opposite labels would switch around. So sine of R is going to equal the opposite side divided by the hypotenuse. Okay, and that is 3/5. And then I'd also actually do tangent of R, which would be 12 over 16, opposite over adjacent, the OA part of SOHCAHTOA. So take each angle and do the three trig ratios, or all of them that are asked for that angle, and then switch. And as you switch, so if we switch to angle S, what switches around is the A and the O switch. Hypotenuse remains the same. So then you do the three ratios with respect to angle S, which I'm not going to do those, but you get the idea. So that's the fifth thing in solving right triangles, is just stating the trig ratio. And that's what a lot of this practice is down below. Notice that on these two triangles, you just have two of the three sides given. So you will need to do the Pythagorean theorem to find the remaining side. How is the Pythagorean theorem done? My advice to you is to trace the right angle. So trace the right angle. I'm tracing the right angle here. That's your a squared plus b squared every time. You don't even think of trying to label it. You just do it, and you'll have your a squared plus b squared. So you can actually just take your calculator and enter that out as 676. And then you would square root that. and that's 26. So C is 26. Now you're ready to begin all the trig ratios. Now I want to do something here with some of the inverse ones. Let's see, let me figure out side C on this one down here before I start. So 18 squared plus 24 squared, and then square root, this is 30. Okay, so let me talk about these reciprocal ratios. So angle D, no matter what, you need to go up to angle D and you need to pick it and label your sides adjacent, hypotenuse, and opposite. So how do you know what side's what? Well, the O and the A make the right angle. And the A is always hooked to the acute angle that you choose. You do not choose the right angle. You choose angle D or E. It's one of the two acute angles. And so every time the sides that make the angle that you picked are the A and the H, with the A making the right angle. So secant of D is the flip of cosine. So this is something that you might have to look back on. Secant is hypotenuse over adjacent. So you're going to take the hypotenuse side 26 and divide by 24. Or wherever you see cosine of D, that's up here, it's just the flip. Okay, so 13 over 12 is that reduced ratio. And the same goes for these other reciprocal ratios. So the cotangent is the flip of tangent, and the cosecant is the flip of sine. And if you need to look those up, look them up. Looks like we're switching angles here. So K is here. Okay, so cotangent is the flip. So OA would go to A over O, 18 over 24, which is 3/4. Cosecant of E. So now we got to go up here and label with angle E. So I'm just going to use my purple and go over this. Okay, so it's the flip of sine. So sine is 24 over 26. So we're going to do hypotenuse over opposite, 26 over 24. And some of these will have the same answers. That's okay, because we're literally dealing with the same triangle. Okay, and then I'm going to go again and invert these here. So secant of J, secant is the flip of cosine. So if you knew cosine of J, then you can immediately go to secant of J. So cosine of J is 4/5 reduced. So once you get that answer, you can just say 5/4. So it's about pairing these up. Cosine goes with secant, tangent goes with cotangent of the same angle, and then cosecant goes with sine. So you got to make sure that you're getting the same angle. Or you can just say hypotenuse over adjacent. So this was 30 over 24. That got reduced. Okay, so reciprocal identities, they're called. Don't worry about them. All that you ever will do is just state them within an assignment. So here is more practice with writing ratios. And so on 25 and 26, you need to set these up. You need to do the Pythagorean theorem. Remember, the Pythagorean theorem is trace the right angle. That's your a squared plus b squared. And then we'll call it, excuse me, side d squared, just so you're not getting confused. So it's just the angles that make the right angle are your legs, your a and your b, and you're going to add the sum of those squared equals the third side, the hypotenuse squared, which in this case is d. Okay, so that will be 25. And then you'll have this right triangle to answer all of these. So same thing over here, a squared plus b squared. That's your 30 squared plus 40 squared. Now Not all the time are you just given the two legs. So you'll see up here on this triangle, you have a squared plus 7 squared. Trace the right angle. That's how you know how to set up the Pythagorean theorem. It's literally that simple. All right, moving along in this assignment. So assignment 3 in this pretty big packet is really where the rubber hits the road. You have to be able to do assignment 3 to continue and to be successful at this. So on the front of this, you're going to have only one side that's given. So with that knowledge, I have to start the trig process. What is the trig process? You pick an angle, you label your sides, adjacent, hypotenuse, and opposite, and now you're ready to set up a ratio. Well, how do we know what ratio? Well, look at what you have given. Always helps to write this down too. You have given the opposite and the hypotenuse. With the 6 and the x, I mean. Sometimes you have to put the x in. Here you won't. So that's the sine ratio. So you're going to start out like this. Sine of 30 over 1 equals 6 over x. Opposite divided by hypotenuse. You flow left to right, but that's the numerator, that's the denominator. And then it's a cross product and divide if you have to. So x times sine 30 equals 6 times 1. And then we're going to divide both sides by sine 30. Sometimes you don't have to divide. It just depends on how the cross product works out. So 6 over sine 30. And you do want to make sure, so the online calculator that you'll use is the Desmos one. It's in the learning plan. Just look at it, watch the video. You do need to make sure you're in degree mode as you do this. If you're not in degree mode, you're going to get answers that don't make sense. This is also a 30, 60, 90 right triangle, which you're going to learn about how the hypotenuse is double the side that's opposite the smaller angle. One thing I need to say here, my triangle drawing is bad. They're not to scale, so you have to go with the labels. So it doesn't make sense on this triangle. This 30 degree, this is 60 degrees up here, which means that side needs to be longer technically. So make sure that you're going with the data and not the drawing. The drawing is just something for you to look at. In other words, they're not to scale. All right, problem 3. We've got one side given, so we have to start the trig process. How do I know to label these? Adjacent, hypotenuse, and opposite. How do I know that? Well, the angle that you pick, the A and the H make that angle. A makes the right angle every single time. So here, A, H, and then O is the one that's not a side of the angle that you pick. You cannot pick the right angle. You must pick one of the two acute angles. What to use? You have the A and the H with the X and the 7. That's cosine. Okay, so cosine 63 equals X over 7. And then cross product. This time you do not have to divide. It's just 7 times cosine 63. Again, you might need to, if you're at home, so that's 3.2, you might need to go online to the Desmos. Just look at the video. I'm not going to do it in this video because this video is long enough as it is, but just go on there and it shows you how to use that online calculator that will do these simple calculations at Desmos, the Desmos scientific calculator. But you need to watch the video because there are some things you need to know. All right, so problem 4 is going to be the tangent because you have the O and the A with the 5 and the X. Okay, so tangent 42 over 1 equals 5 over X. Take the cross product, X times tangent 42, equals 5. Divide both sides by tangent 42. and that will be 5.6. So about 5.6. Make sure I'm checking my answers here. That's right. Okay, next page with angles. So how is it that we approach solving for angles? Same thing. Note that you want angle X here. So that's going to tell you what one to pick. And so here we go. A, H, no. Now look at the O and the H, have the 3 and the 8. So that's sine. But the problem is it's sine of X equals 3 over 8. So how do you solve for X? You have to take the sine inverse of both sides. So in doing that, you don't have to write this out every time, but this is what's going on. You take the sine inverse of both sides, and on the left, it knocks out the sine. So X is sine inverse of 3/8. Well, if you know that, you don't have to write that out every time. You just go right to sine inverse of 3/8. And that you get by doing second function sine. And again, on that video of the decimals, on how to use the decimals scientific calculator, it shows you how to use the inverse keys. So you need to look at that. 14, same approach. Here's the angle you pick, adjacent, hypotenuse, opposite. This is a tangent inverse. You got to make sure you do O over A, O divided by A. So tangent inverse, this will end up being tangent inverse of 4/3. So anytime you do inverse trig function, you're figuring out an angle. So 53.1 degrees. Once you get these, they're very simple. Adjacent, hypotenuse, opposite. So this is a cosine because the A and the H. So cosine inverse of 4 divided by 5. A divided by H, because you follow the acronym. Cosine equals adjacent over hypotenuse. Sine equals opposite over hypotenuse. Tangent equals opposite over adjacent. So that's what you do. If ever you get an error, you have done it wrong, because if you enter things wrong, it's likely you might get an error message. I'm just saying so that you're aware of that with these. All right, so on to even more crazy full-blown practice. So this is solving an entire right triangle. And again, I've provided way more than you need, but you need to be able to do this. Okay, so I'm going to do 6 of these and then briefly mention the word problems at the end, and that'll be it. So angle B, 22.6 degrees. So 90 minus 22.6 is angle C. That's 67.4, or 180 minus 90 minus 22.6. This is side B, 5. So it's the side that's opposite the larger. So this is B, this is A, this is C. Opposite the larger letter, which is the angle. So side A is 13. And side C is 12. And one thing you can do to check this out, it has 2 things have to be. The largest side's opposite the largest angle, which of course is the right angle, which is of course the hypotenuse. Middle side opposite the middle angle, smallest side opposite the smallest angle. So that has to work when you pair these up. Also, A squared plus B squared has to equal C squared. Now, I'm going to tell you, the A, B, and C do not always work out on this. It's the legs squared. So you got to trace the right angle, because I can put any letters down I want on a right triangle. So you have to trace the right angle to do this. All right, so on this one, here's 90. We don't know those two, but we know side A is the square root of 2, and we know side B is the square root of 2. So remember, just go opposite. And we know side C is 2. Well, to save a little bit of fuss, and you don't need to set up an inverse trig. You could, if you wanted to. See, both of those sides are equal, so the angles are. So that's the one time you would not have to do that. Other than that, you'd have to set up an inverse trig expression to figure an angle out, which we'll have to do later on. So you really didn't miss out on anything. First step, you want to write down everything you know. Angle A is 30. So by angle sum, that makes angle C 60. And then this is 1 and 2. So all we're missing here is one side. Well, that's the Pythagorean theorem. Well, how do you do the Pythagorean theorem? Well, trace the right angle. I'll call this lowercase c, this side. So you see how it's not a squared plus b squared equals c squared. It's, you trace the right angle. So the sum of the legs squared equals the hypotenuse squared. That's what's going on. But just trace the right angle, then you'll see. So c squared is going to equal 3. So c is the square root of 3, which you can write, or you can decimalize at 1.7, either way. Problem 4, moving right along. Angle A is 90. We don't know B or C, so we're going to have to use some trig here. Side C is 8. Side A is 30. Let's get side B first. So remember, trace the right angle. That's how you know what to do. So B squared is squared minus 9, minus 8 squared, excuse me. So 836. Now, a lot of times these are not going to work out to be perfect. So you can just square root them. 28.9 is side B. Okay, so what about the other two angles? Well, you have to do the trig process when you only know one. You're forced to. So I'm going to pick angle C here. Remember, adjacent, hypotenuse, and opposite. And I've got an O and an H with nice whole numbers. You could use the 28.9, but I'm not going to. So that's the sine inverse of 830. That's what we want to do. That's what it's going to work out to be. Now we can do that whole setup. Sine of C equals 8 over 30, and then do the sine inverse on both sides. You don't need to do that. You just do sine inverse, cosine inverse, tangent inverse to get the result. So 8 over 30 is 15.5 degrees for C. And then you do 90 minus 15.5, and that's 74.5. And as you check this out, it better be that middle side's opposite the middle angle, smallest side's opposite the smallest angle, and largest side's opposite the largest angle every single time. Okay, so angle C is 90, angle B is 52, and by angle sum, 38. So 90 minus 52. And side B is 12. And we don't know side A, and we don't know side C. I'll put those in. So begin the trig process. So A, H, O. Again, adjacent, hypotenuse, opposite on the inside. So it doesn't really matter. I'm going to go for side C first. And so that is the O and the H that have the 12 and the C. So that's sine. So sine 52 equals over 1 equals 12 over C. So you can do the cross product. So C times sine of 52 equals 12. So C is 12 over sine of 52. And that is 15.2. Okay, and that was side C. And so you can, from there, do the Pythagorean theorem to get side A. So remember, trace the right angle. A squared plus B squared. So A squared, not the same idea though, plus 12 squared equals the 15.2 squared. Okay, and when you solve that, I'm not going to do all that work, but when you solve that, you get 9.4. But just trace the right angle to determine how to set up the right triangle. All right, moving very quickly through this. B is 90, making angle A 70. Side A is 24. Okay, and so we can do this. I'm going to pick up here, so adjacent, hypotenuse, opposite. See how I do that every time. Adjacent, hypotenuse, opposite. So we have the 24 and the B. I'm going to use those first. So that's cosine of 20. So A and the H equals 24 over B. So B times cosine of 20 equals 24. So B equals 24 over cosine of 20. You divide. Divided by, after you cross multiply, cosine of 20. So 25.5 is B. That's a 20 in there. All right, so side C then. So B is 25.5 right here. Work is a little bit sloppy. You trace the right angle. So we have C squared plus 24 squared equals 25.5 squared. Okay, and then you solve this out, which I'm just going to do real quick, and you get 8.7. And then just make sure as you check your data that, you know, again, smallest side opposite the smallest angle, middle side right here is 24 is opposite 70 degrees, and then largest side 25.5 is opposite 90. That has to work every single time. If that's not working, then you did something wrong. All right, moving on to some problems at the end. So make sure you do enough. And I've given you way more than you need, but you need practice. So here are some problems. I've given you the right triangle. A lot of times in this, you have the angle that's given is called the angle of elevation or angle of inclination. I like the ladder problem, so that's why I'm doing this one. And then how far up the vertical wall. So here is the ladder. This is the vertical wall. This is how far the ladder is from the base of the wall. We want to know what X is. So my advice to you is to try to get these set up correctly before you even go to solve them. Okay, so we're 60 feet above the ground. If your eyes, okay, and the angle of sight, the angle made between your line of sight and the building is 25. So here's the building. About how far is the clown from you? So here's the clown down here, and here's you. So that's how that particular problem gets set up. Most of the time, the angle that you're given is this angle that's made up from the ground called the angle of elevation. And the other one that I want to set up is, again, this wonderful ladder problem on this page. And it makes with the ground is 70. And so we want to know how high up. Well, I'll literally use A and B. So that's the answer to A when we solve for side A. And then this is the answer for B. So let's do some of these. Let me get a different color here so I can, I probably should have been doing that all along. All right, so we're going to pick this angle, adjacent, hypotenuse, opposite. Notice what's given. The O and the H have the X and the 4, so that's how you know it's sine. So we got sine of 75 equals O divided by H. So X equals 4 times sine 75. So you don't need to divide in this case. A lot of times you do need to divide, so beware. So this is 3.9 meters when you do that product out. Okay, here, so adjacent, hypotenuse, opposite. This is going to be a cosine because it's the A and the H. So cosine of 25 equals 60 over X. Cross product, X times cosine of 25 equals 60. So X is 60 over cosine of 25. You're going to divide both sides by cosine of 25 to solve for X. and then that is 66.2 feet. Make sure that you do this, because sometimes on standardized tests, they actually put the answer choices in this, like this trig format here. So they won't actually work it out to the numeric answer. All right, and then we'll finish up with problem 8. Okay, so adjacent, hypotenuse, opposite. So on this first one here, to solve for A, that's going to be a sine setup. So sine of 70 over 1 equals A over 30. And A will be 28.2 feet. And then for B, that would be cosine, because we're looking at this variable B here, and then the 30. So A and H have the labels. So cosine of 70 over 1 equals B over 30. So B is approximately 10.2 feet. So keep in mind that this won't be perfect because there's rounding, but the Pythagorean theorem always has to hold. Now again, this won't be perfect, a little bit off. So there's the test, 10.2 squared plus 28.2 squared approximately has to be 900 squared, but we rounded, so that's why that's not perfect. But that Pythagorean theorem always has to work. To do the Pythagorean theorem, you trace the right angle. Those are the two sides you add together squared. And so this video just covered your first assignment for quiz 3.